The next part of our project to connect the RGB LED is to actually understand what a schematic is and to be able to wire it up on our breadboard. So if I make a schematic, it's basically a very simple drawing to show the connections that are happening in a circuit. So for example, here I've got a square or a rectangle box that represents the Arduino. It doesn't look exactly like an Arduino, but I understand what it means. I can see the digital pins and what they're connected to. So for example, here you can see that I have connected or drawn so that the digital pin 13 is connected through a resistor to an LED and then back into ground. So that's just a very simple schematic for how I might go ahead and wire things up. It looks a little different as the wires go, but this tells me what gets connected to what. We need to understand what exactly this light emitting diode is and how it gets connected, what all those wire leads are. An RGB diode or LED, light emitting diode, is one that actually has a red LED, a green LED, and a blue LED all housed in this little cap that helps distribute the light. So there's a lead for the red, the green, and the blue, and I can turn them all on, and I can turn any combinations of them on, and I can get basically any color I want by using these three LEDs, these three colors. They are connected to a common cathode. That means that they have a supply voltage will come from this side, and then it will go to the ground on the common cathode. So we'll need to connect up a resistor to each of the red, green, and blue pins, and then the common cathode gets connected to ground. Now you can see that there are different lengths, and each of these different lengths represents one of the leads. I kind of like to look at it as kind of like the fingers of your hand. So if you take a look at the fingers of your hand, the index finger kind of represents the red lead, your middle finger or your longest finger would represent the common pin, and then ring finger would be green and pinky finger would be blue. So that's kind of to help you remember how it's how those leads go without having to look at the data sheet every time. Another thing that you can see from this schematic drawing or this data sheet drawing of an LED is that if you look down at the top of one of these LEDs, it has a little ledge around the bulb part, but that ledge is sort of not there, and it's flush on the side where we have the red lead, red pin. So that's another way that you can tell. Once it's all plugged into a circuit, it's sort of difficult to tell because you can't see the lengths of the different wires. So if you look just from the top down, the side where the little lip is flush with the bulb is the red lead side. So that can help you identify the wires on your LED. Again, we're going to be using this breadboard, and we're using the fact that the rows are connected like a wire and these columns along the side are connected like a wire. So we can create a circuit with our red, green, blue LED and our Arduino. So what you see here up at the top is just a schematic. We're going to connect from the Arduino, and these pins are going to be a little bit different. I actually have the digital pin 11 and 10 and 9 are what's connected here. So digital pin 11 will be connected through a 470 ohm resistor to the red lead on the LED. Digital pin 10 connected through a 430 ohm resistor to the green. Digital pin 9 connected to the 430 ohm resistor to the blue pin. And then on the other side, the common pin is going to be connected to ground. Now these pins are a little bit bendy. You got to be a little careful because bending a wire too much will make it break. It will fatigue the metal and it will break. But you can bend it a little bit. So we're going to take this LED, and each of these represents one of the leads on the LED. I've colored it red for red, green for green, blue for blue, and purple just is the common pin. And I'm going to spread them out such that I can put a little space in between each one of them so that I have room for this resistor to be part of the circuit. So if you bend your LED such that it looks kind of like this and it straddles the center divider and the common pin is on the other side of the center divider, we can then use these little resistors to straddle. It's going to go from, like for this example, this resistor is going from row 17 over to row 16, and that's where I have the red lead for the LED plugged in. So if we trace the circuit, it's coming from digital pin 11. I've got a wire that's going to connect from digital pin 11 to row 17 where the resistor gets plugged in, and that goes to row 16, which is connected to the red lead, and that is through the common pin then to what I'm going to make a ground rail. So everything connected to this column is going to be connected to ground. So I connect it to the column that's ground, and then the ground column gets connected to the ground pin on the LED. Similarly for green, connects here through the resistor to the green lead, and then to the ground through the common pin. And for blue, through its resistor to the blue lead, and then to ground through the common pin. So that's how it's going to be wired up. We'll go ahead and show you how that looks on a video. Now we have to be able to program the LED to turn on, and we can actually program it to turn on a different color. We're going to be doing something very similar to how we programmed just the built-in LED. And all we have to do is really just replace the pin numbers that we have connected our LED to, replace this LED built-in with those pin numbers. So to do that, we're going to start with the blink program, and I first have to save this. I'm going to save it as a different, so I've opened the blink program file, examples, basics, blink, and that's where I got blink. So I've opened this program, and now I'm going to save it as something else. So we'll save as, and we'll call it, we have to name a folder, the same thing that we're going to call it, and it needs, the script needs to sit within that folder. So I'm going to call this blink RGB example. So open that up, and we'll name it blink, name the file blink RGB example. And then we have a new script placed wherever we want to have it placed. So we can change the comments later. I'm going to focus on the code down here. Before we have the setup function and the loop function, we have to define some color pins, and we have to define, give them some names and connect them to the numbers of the digital pins that we have things connected. So to do that, we define a const and we call it an integer because it's going to be an integer. So this is a constant value that will be an integer, and I'm going to name it for the red one, red pin, and it is connected to digital pin 11 on the Arduino. So I have created this definition for the computer that anytime I type in red pin, I actually mean 11. And I can do the same thing for the green and the blue leads, or the green and the blue. So I'm just going to copy and paste, and instead of red, we'll call it green, and that's going to be connected to 10, number 10 pin on the Arduino, and then blue will connect to 9. Whoops, 9. Okay, so that means that I have those values. Now anytime I type red pin, the computer will translate that as 11. Same thing for green and blue. Now we need to do the same setup. We need to initialize the pin for the red, green, and blue. So we'll initialize the digital red and blue pins as outputs. To do that, we use the same function. So I'm just going to copy this and paste it, because we're going to do it 3 times. And instead of LED pin built in, I will replace that with red pin and green pin and blue pin. I'm just copying and pasting those. So that initializes all of those LED pins to be outputs. That means it's going to be sending information. And now all I have to do is adjust these digital write statements to turn it on, and then delay for a second, and then turn it off and delay for a second, and we'll be able to blink our LED that we've wired up, just like we did with the built-in LED. So I'm actually going to copy the whole thing here and paste, and again I can copy and paste the pin names down here, and I can fix the comments later. But this will turn the red LED high, green LED high, blue LED high, and then we can do the same thing to turn it low, which will turn it off. So okay, so now I have the basic code that I need to be able to flash the LED on and off, and we'll take a look what that looks like with the camera. So you can see that it's flashing the built-in LED. That's the program that's the last code that I uploaded to this Arduino. So as soon as I plugged it in, it started running that code again. And now I'm going to click upload so that I upload my new code to the Arduino, and it should start a different function, should be doing something different. So we can see it receive the information, and now the LED that I have is turning on and off, and it's turning on and off white. So if I combine all of the red, green, and blue LEDs combine them all together, I get white light. I can decide to maybe say I want to combine red and green. I could comment out, or sorry, red and blue. I could comment out the green pin and have it just ignore that green pin and upload. What did it not like? Oh, I'm using the wrong slashes. So I want forward slashes, not backslashes. Try again. That was an example of it telling me there was something wrong with the code, so I needed to go back and see. And now you can see that it's flashing sort of this purple color. So the combination of red and blue gives purple, which means that I can control whatever color it is that I'm flashing on this LED by controlling the combination of the red, green, and blue. Next, we'll talk about how we can control the intensities of each of these individual pins so that we can get even more variation of color. So I've gone ahead and changed the comments here so that we can see that it's the red LED and green and blue LEDs that we're turning on and off. You can see that I'm still blinking that purple color. We're going to make one more change here. I'm going to uncomment these digital write statements, and what I'd like to do is be able to control whatever color I want. And if you Google RGB color codes, you'll come up with some sort of chart like this. And basically these are the mixture values of intensity from 0 to 255. 0 being none of that color, 255 being the maximum of that intensity of that color. And any color you pick will have a combination value of red, green, or blue. So I can look down here in this color chart and choose something, let's say maybe this green or something like this. Well, that's all green. So how about maybe we choose, I don't know, this turquoise color. Or maybe I want to choose orange or something like that. I can choose any one of these and it will give me the color codes. Let's do this yellow-green. That's a nice combination of everything. Well, it will give the color codes down in the bottom here, red, green, and blue, for what we need to enter in for an intensity if we want to have that mixture. So if I go and choose, go back up to my sketch, we can use a different function. So rather than the digital write, we can use an analog write. And once it recognizes that I'm using a function that it knows, it'll turn red. I still need to tell it which pin I'm going to turn on, but instead of high, I'm going to give it a number, intensity number, just like what you have in those color codes, RGB color codes. So for that green that we picked, we had 178 for red, and instead of turning on high, we're going to change the comments so that we know that we're turning on an intensity level. So we'll do the same thing for each one of the, each one of the other pins, and we'll choose another value so that we can get a mixture. So go ahead and play around with that. Choose different colors, see what color of LED you get, and now you have control over whatever color you would like that LED to flash.